Next, topic 4, we've got these sum and difference identities. So with these ones, you want to figure out how you can use unit circle values to rewrite whatever angle they have there. So 345, and these are, remember, there are multiple options. I'm just going to use just the first one that pops into my head. So I'm going to go 300 plus 45. All right, so your tangent formula, you have the tangent of A plus, this is the sum formula, the tangent of B, and then in the denominator, you have 1 minus the tangent of A times the tangent of B. So these require unit circle knowledge. You need to know what value you're getting off the unit circle, and these we've been talking about for a while. So 300, the reference angle for 300 is 60. The tangent of 60 is just one that you should have memorized. The tangent of 60 is the square root of 3, but since 300 is in the 4th quadrant, you need to add a negative sign, plus tangent of 45, we should know that one is a positive 1, and then just use those values in the denominator. So 1 minus negative root 3 times 1, and then just clean it up as much as you're able to. So we have negative root 3 plus 1 over 1 plus root 3. Now here we need to rationalize the denominator because we cannot have that root. So what you do, since it's a binomial, is you multiply by its conjugate. So we can get a final answer here. All right, so first we have negative root 3 times negative root 3. So that ends up being, a positive 3. Outside, we have, oh no, sorry, I did that right. Did that right the first time. This is the outside term, the negative root 3, negative root 3. So let's just write that down first. First, we have negative root 3 times 1, and then another negative root 3 times 1. So that's negative 2 root 3. And then 1 times 1, of course, is 1. Sneak that in. Over. Denominator, 1 times 1 is 1. Outside term, inside term cancel. That's the whole point of the conjugate. And then minus root 3 times root 3 is 3. Okay, so clean that up. So we end up with, this is a 4 minus 2 root 3. The denominator is a negative 2, so we can divide out that negative 2, and we get negative 2 plus root 3. That's our lovely value here. All right, sine of negative 195. We could do, let's say, 45 minus 240. That's one way to get negative 195. So that's a subtraction formula. So sine of A minus B is sine cosine minus cosine sine. So sine of 45, cosine of 240 minus cosine of 45 times the sine of 240. So 45, unit circle value that you should know. That sine is root 2 over 2. 240, the reference angle is 60. The cosine of 60 is 1/2, but 240 is in the 3rd quadrant, so we make it negative. Minus cosine of 45 is a 1st quadrant unit circle value you should know. 240, again, reference angle is 60. The sine of 60 is root 3 over 2, but this angle is in the 3rd quadrant. Okay, so multiply those out. This numerator is a negative root 2 minus negative root 6 all over our common denominator. Okay, 6, we have a negative pi over 12. So hopefully the more practice you guys got with these, the easier the radians were. So for negative, think of that as like negative 1 over 12. So that could be 2 pi over 12 minus 3 pi over 12. So that would be pi over 6 minus pi over 4. So not the easiest, but the more practice you get with radians, they'll feel easier. So the cosine formula is cosine cosine plus sine sine. Remember, cosine actually has the opposite sign of what it seems like it should. So cosine cosine plus sine sine. Okay, so those values, these are all just 1st quadrant values. All right, so cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Plus sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. So all of it we know is definitely over a common 4. Root 3 times root 2 is root 6, plus 1 times root 2 is root 2. Okay, and one more of these, again, a little bit tricky. The 19 pi over 12, remember, anything over 6, over 4, over 3 can be made to have a denominator of 12. So we could do 3 pi over 12 and yeah, that would work. 3 pi over 12, and then that would be 16 pi over 12. Yeah, that'll work. Not the best, but so 16 pi over 12 is 4 pi over 3. 3 pi over 12 is pi over 4. So those are unit circle values, so we can use those. So we do another sum there, so it's this same tangent formula. So we have tangent of 4 pi over 3 plus tangent of pi over 4, denominator 1 minus, and then you multiply the values together. Okay, so we've got equals. We'll start piecing some things together here. So tangent of 4 pi over 3, that reference angle is pi over 3, and the tangent of pi over 3 is root 3. Here, this is in the third quadrant, and the third quadrant tangent is positive, so we don't have to change this. And then plus 1 over 1 minus root 3 times 1. So we're actually in like almost the exact same scenario that we were in for that first example. We still have to rationalize the denominator here. All right, so we are going to multiply this by the conjugate of the denominator, and I'll do all the work down below. All right, so first one. First is root 3. So for our roots, we have root 3, so that is a 2 root 3. And for our numbers, we have 1, and then this multiplies out to a 3. So 1 and 3 multiplies out to 4, or adds up, I'm sorry, to 4. First, we have 1 times 1, which is 1. Outside, inside cancel, that's why we use the conjugate, and then minus to 3. So this is almost the exact same. So here, this is a negative 2. So when we divide everything by a negative 2, we end up with that. Okay, next step. So now pay attention to our quadrant here. So from 3 pi over 2 to 2 pi, this is in the fourth quadrant. So make sure you know that. So for instance, in that quadrant, the sine values are negative. So really just cosine and secant, if you need it, would be positive. So sine of a minus b. So you're given a couple values. You have to figure out the rest. So these ones, we stick with Pythagorean triples. Remember that. So for angle A, here's A. So the sine is negative 3 over 5. The hypotenuse, never the negative 1. So we have opposite over hypotenuse. This would be a 3, 4, 5 triangle. Cosine is positive, so the 4 is positive. And then angle B. This one I give you the cosine. So cosine is adjacent over hypotenuse. And then this is a 5, 12, 13 triangle. Remember, fourth quadrant. So that would be the y coordinate, and it's negative. So write down the formula. Sine of a minus b is sine a cosine b minus cosine a sine b. And then we just sub in the values, either the two that you're given or the ones that you can figure out based on those triangles. So sine a was given, cosine b was given, minus, okay, so cosine a, here's a. Cosine would be the adjacent over the hypotenuse, so 4 over 5. Sine b, here's b, sine would be the opposite over the hypotenuse, so negative 5 over 13. All right, so these could cancel, but we don't want to because we want the denominators to be the same. So numerators are negative 36, denominators are 65, minus numerators are negative 20 over 65. So negative 36 plus 20 ends up being a negative 16 over the common denominator. All right, 19, similar. So let's write down the formula that we need. Cosine, cosine, remember opposite of what you'd think, so minus sine, sine. Okay, so we have cosine, we have tangent. So we're still doing the exact same thing, it's just that tangent happens to give you two different pieces of the triangle. So here's A. Cosine is adjacent over hypotenuse. So this would be an 8, 15, 17 triangle. Remember, fourth quadrant, negative y. And this is B. Tangent is opposite over adjacent. So the 3 is the negative one, 4 is positive. This is a 3, 4, 5 Pythagorean triple. So cosine A is given. None of the other three are given. So cosine B, this is B, adjacent over hypotenuse, minus sine A, so here's A. Sine is opposite over hypotenuse. And sine B, again, here's B, opposite over hypotenuse. Okay, so multiply these out. 8 times 4 over 17 times 5 minus, and then these are both negative, so positive 45 over 85. So subtract these. 32 minus 45 is a negative 13 over the common denominator. Does not reduce down at all. All right, and then one more, very similar setup here. So this time we need the tangent of both of those terms, right? So let's write down the formula. So we need tangent of A minus tangent of B over 1 plus tangent. Okay, so we need tangent of A and tangent of B. We're not given either one of those, but just like these ones, we can make a triangle and find it. Okay, so here's A. Sine would be the opposite over the hypotenuse. And if you recognize this one, this is a 7, 24, 25 triangle. And B. Sine is opposite over hypotenuse. This is a 3, 4, 5. So let's fill in those pieces. So tangent of A, tangent is opposite over adjacent. So opposite over adjacent minus tangent of B, again, opposite over adjacent, over, okay, so now 1 plus, and then these same two values multiplied this time. Okay, so let's combine everything up here. So this one, we need a common denominator. So for this, I'm going to multiply by 8 over 8. So this would be 24. This would be negative 32. Okay, so just getting a common denominator. So negative 7 minus negative, so plus. This ends up being 25 over 24 over 1 plus. It still will be plus because those are both negative. So I get 28 over 24 times 3 is 72. All right, so let's combine all our like terms here, see what we can figure out. So numerator, now this, think of this as 72 over 72. Okay, so if I do 72 and I add that to 28, I end up with 100 over 72. So I'm going to take this lovely value here, and then I can do, multiplying by the reciprocal to figure out my value here. All right, so I would take 25 over 24 times the reciprocal, and I can reduce down quite a bit. So 25 over 100 is 1 over 4, and then 72 divided by 24 is 3. So this just reduces down to 3/4.